A lead weight on a spring is oscillating up and down. Its position at time t with respect to a fixed line, horizontal line, is S of t equals t. Determine the value of v of 0. Okay, so v of 0 is S prime of 0, which is the limit as h goes to 0, of, well, that would be a plus f of a plus h. So in this case, s of a plus h. Okay. Oh, I guess I should go ahead and use that version of it, shouldn't I? All right, so we'll go ahead and do that is the limit as t approaches 0 of s of t minus s of 0 over t minus a, so that will just be t. Well, if you evaluate sine at t and sine at 0, this is the same as the limit as t goes to 0 of sine t over t, which we happen to know is 1. So v of 0 is 1, as we discovered in the previous chapter. Next question, we have a rock dropped from a height of 64 feet. So the position is given by this function we have. So we want to find the instantaneous velocity 1 second after it's dropped. So that would be v of 1, which is s prime of 1, which is the limit as t approaches at this point 1. And if we evaluate that function at t, so negative 16t squared, actually we're going to have to evaluate that at t, yeah, we can just stick with that. Now, negative 16t squared plus 64 minus, evaluating it at 1, gets us 48 divided by t minus 1. So once we combine terms there, limit as t goes to 1. Okay, combining terms, I get negative 16t squared plus 16 over t minus 1. Now, I'm going to bring this over the next line. If I factor out a negative 16, now leave that limit as t approaches 1. If I factor out that negative 16, I get t squared minus 1 over t minus 1. And that is going to cancel to be the limit as t approaches 1 of negative 16 t plus 1. Now, if I evaluate that, that is negative 32. Therefore, v of 1 is negative 32 feet per second.